Hello and welcome to the Electrostatic Field Plotting Laboratory exercise. In this laboratory exercise, you're going to be looking at equipotential voltage lines around different shaped conductors. So the conducting configurations that you're going to be looking at are parallel plate capacitors, so two rectangles with a distance between them like this, concentric circle conductors, so a circle in the middle and then a big circular plate or disc around the outside, and then two circles separated by a distance. So the aim of this experiment is to compare the theoretical voltage difference with the ones that you actually measure in the laboratory. So the first step in this is that you need to come up with an expression for the voltage difference and how it changes with distance. So in order to do that, you're going to need to make use of the expression, the potential difference is given by minus the integral of E dot dr, where E is the electric field and R is the distance vector, and it's between 2 points A and B. So if we're looking at these parallel plates, we'd call this distance here A and this distance here B. So we're looking at how the voltage changes as we move from plate A to plate B. So in order to work out this voltage difference, you need to know what the electric field is. The best way to calculate the electric field is to use Gauss's law, which tells us that if we have a closed surface, then the integral of the electric field over that surface is equal to the charge enclosed within the surface over epsilon naught. So in the first theoretical problem, you're going to need to come up with an expression for the electric field for this parallel plate capacitor. And I'll give you a little hint about that. A cylinder like this works well for your surface, so you may want to consider using something like that. So once you've got an expression for the electric field, you can then substitute it into this to get an expression for the voltage difference and how it depends on the distance. So in this case, we call A as at distance 0, and B is given to you in your lab manual. You can look it up. It's what the physical distance actually is if you measured it with a ruler. So what you'll then be doing is plotting graphs. So what we want to see is how does the voltage depend on the distance. So you'll be using this theoretical expression. You'll come up with something, and when you know the distance A and the distance B, you'll substitute those in and distances in between, and you'll plot something which may end up looking something like this. Then when you come to the laboratory, you'll actually measure the voltage at different distances along here and plot it on the same set of axes, and you will find out, are these in agreement or are they not? Once you've done it for the parallel plates, you'll do it for these other configurations as well. Because we're so kind, we've actually derived the expression for the electric field in these configurations, and so you're just going to need to take into account the distances and substitute those in. They're given in your book so that you can get an expression for these ones of how the voltage changes with the distance as we work our way out from the center and from one of these dots to the other. So if you want to come really prepared to the lab, after answering the pre-work questions on Moodle, you could also plot these voltage versus distance theoretical results for these three configurations, and then you just need to take the experimental measurements in the lab. If you're finding it really challenging, you can ask your demonstrator about how to do this once you get to the lab. This is the equipment that you're going to have available for this experiment. So you have 3 sheets of slightly conductive paper with the plates printed on them in very conductive graphite. You have a power supply, which you'll be outputting 12 volts DC electricity from. You've got a voltage meter so that you can measure the voltage, and you've got a few wires and a pointy probe like this. So what you'll do is you'll ground one of your plates with the concentric circles. Make sure that the two outside bits are plugged to the same side on the power supply. So you want your inner ring at ground and the two outside bits at the 12 volts. You don't want to put ground here and 12 volts there. So once you've set it up, you'll then be measuring the voltage at different parts around this setup. So just push very gently, don't make holes in the paper with the probe, and you'll want to find points where the voltage is 10 volts, so you'll just read it off here, points where it's 8 volts, 6 volts, etc. Remember to have a look around the outside of these plates as well, not just in between. For your graph, you will just be plotting the points in between, but for the rest of the questions, you should have a bit of a look at what's going on outside as well. Feel free to draw all over this paper. It's yours, so you can draw over it with pencil. If you find there's an 8 volt point here, you may want to put a cross there and write 8 volts next to it so that you can easily interpret your result.